Good morning, guys. Today's lesson is about the properties of multiplication. And at the beginning of the lesson, you know there are always anchor charts up at the top of the page. You're going to want to use them today, okay? It's going to be really important that you're going back and forth between the anchor charts and the questions to help you remember the properties because there's 5 of them and we haven't talked about them in a while. So I'm going to go over them with you really quick. And hopefully it will help refresh your memory. So the first property that we're going to talk about is a pretty straightforward one. It's called the zero property. The zero property says any number times 0 equals 0. Duh, right? You guys know this about the zero property. 3 times 0 is 0, 9 times 0 is 0, 1,457 times 0 is 0, smiley face times 0 is 0. It goes for anything, okay? The next property is called the identity property. The identity property says any number times 1 equals itself. Okay, and this is something else that you're familiar with. 3 times 1 is 3. 9 times 1 is 9. 10 times 1 is 10. 11 times 1 is 11. 1,457 times 1 is 1,457. Smiley face times 1 is smiley face. Easy peasy, right? That's the identity property. And identity, I want you to think about this word. Identity, what it means is who you are. Your identity is who you are, right? So think about it like that. Who you are, if you are 3, that doesn't change if you multiply yourself times 1, right? Your identity stays the same. Who you are stays the same. Next, you have the commutative property, and that's the one where we switch the numbers back and forth. And then if you're in class, we did that dance, right? So the commutative property says switch the order of the factors and the product stays the same. So for example, 4 times 2 is 8. 2 times 4, we switched the numbers around, still 8, right? Nothing changes. So that means 2 times 4 equals 4 times 2. These two facts are equal to each other. They're the same, right? They give us the same answer, so we can put this equal sign between them. Next, you have the commutative property. Another example here. 3 times 6 equals 18. 6 times 3 equals 18. Okay? We switched the order of the factors, right? Here, the 3 came first. Here, the 6 comes first. But that doesn't change our product. Our product, 18, stays the same. So we can say 3 times 6 is the same as 6 times 3, right? These two facts are equal to each other because they give us the same product. All right? The next property you might have a little bit of trouble remembering because we didn't use it very much, but it's not hard to figure it out. And that one's the associative property. The associative property says that changing the way factors are grouped does not change the product. So with the associative property, you're usually looking at 3 factors, right? Take a look at just this first example for now. 1 times 2 times 3. Okay, these 3 factors. And you can see that they're grouped using what? What are these called? Do you remember? They're called parentheses, right? So we've grouped the factors 1 times 2 together in the parentheses. That means we're going to solve them first. Okay, and you guys know what 1 times 2 is, right? 1 times 2 is 2. So we drop that down here, but we still haven't multiplied times 3 yet, right? He's going to come last because he was outside the parentheses. So 1 times 2 gave us 2. Now 2 times 3 equals 6, right? Not too tricky, okay? Now we have a very similar looking equation here, right? Look at the difference between this and this. Can you see what they changed? Here, sorry. Can you see what they changed? Look closely. They changed the way that the factors are grouped. So if you look here, our parentheses were around 1 times 2. Here, our parentheses are around 2 times 3. Did our factors change? No. 1 times 2 times 3, 1 times 2 times 3. The factors stay the same. It's the grouping, the parentheses that changed. Okay, so starting off here, we want to multiply the factors that are grouped together, 2 times 3, which is 6, right? And then we have this last little lonely guy on the end. We haven't multiplied with him yet, so we bring him back down. We have 6 times 1, which equals 6. So these 3 factors stayed the same. Their grouping changed, right? Here we have 1 times 2. Here we have 2 times 3. Did our product change at the end, the purple 6? No, the product stayed the same. That's what the associative property says. It says you can change the groups all you want as long as you have the same 3 factors, 1, 2, and 3, or whichever 3 numbers are used in that example, then you're going to get the same outcome. And here it just shows you that this top equation, 1 times 2 times 3, grouped this way, and this top equation, 1 times 2 times 3, grouped this way, they are equal to each other, right? They're equal to each other because they both produce the same product, 6 and 6, no matter what, okay? Now let's take a look at the distributive property, okay? Probably the most challenging property. And just a note today, when you're looking on the assignment for equations that are the associative property, you're probably looking for 3 factors with parentheses, and the parentheses change, right? That's what associative property is all about. Parentheses or grouping that has changed. Finally, we have our friend, the distributive property, and sometimes I call this the divorce property. The distributive property says you can break apart one factor into addends, which are the numbers that add up to create it. So for example, 12 breaks up into 10 plus 2 because 10 plus 2 equals 12. So you can break apart one factor into addends to create 2 smaller multiplication facts that you can solve. So let's take a look at that and remember how the divorce property works. So the divorce property says 12 breaks apart into its addends. So I like to say, right, this mommy and daddy, they get a divorce, 10 plus 2, okay? And even though they've gotten a divorce into 10 plus 2, they're both going to see baby 10, right? So first we have mommy sees the baby, 10 times 10, 10 times 10. And then we're going to have daddy see the baby, right? 2 times 10. Okay? And then we're going to add these. See, we're going to carry this addition sign down. 10 times 10 is 100. 2 times 10 is 20. 100 plus 20. You can stack that up off to the side. You're definitely going to need paper to do the distributive property. 100 plus 20 equals 120. And 12 times 10 equals 120, right? Let's try another example of the distributive property. I know it's been a while since you've seen this. So we'll do, it doesn't matter what numbers we do. How about 9 times 3, okay? Usually the bigger number gets broken apart, but sometimes, don't ask me why, people break apart the smaller number. So 9 is going to break apart into its addends. That means 2 numbers that can add up to make 9, and you have a lot of choices there. You could do 1 plus 8, okay? But usually or you could do 2 plus 7, but I like to do 5 plus something because I'm going to have to multiply these numbers, and I like to multiply 5 because it's easy. Do you know 5 plus what equals 9? What number can you add to 5 to get 9? 5, 6, 7, 8, 9. 5 plus 4, right? So mommy and daddy 9 get a divorce. They break up into 5 plus 4. They're still both going to see baby 3. Okay? So first mommy sees the baby, 5 times 3. Then daddy sees the baby, 4 times 3. And these are both going to get added together at the end, right? 5 times 3 is 15. 4 times 3 is 12. We have to add those up to see if we're going to get the correct answer here. And I like to stack them. I don't like to do it in my head because I don't want to make a mistake. 5 plus 2 is 7. 1 plus 1 is 2. So this equals 27. Does 9 times 3 equal 27? Do you know? Let's check. 3, 6, 9, 12, 15, 18, 21, 24, 27. Oh, good. 9 times 3 does equal 27. That means we did our distributive property problem correctly. Good luck with today's lesson. I believe in you. Please make sure you're going back and forth to those anchor charts. And anytime you see an equation, work it out. Solve it. Don't just randomly pick one that looks good because it has the same numbers as in the question. Do the math. It's good for you. It's good practice.